Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you wherever you are in this part of the globe. And this is the DADM 3 which is Data Analysis and Decision Making 3 course under NPTEL MOOC series of lectures. And as you know, this total course contact hours is 30 hours, which is split and made into 60 lectures, each lecture being for half an hour, and the total duration would be basically for 12 weeks. And after each week, where each week you have 5 lectures, each being for half an hour, as I told you, we have an assignment. So, you have all as you can see from the slide, this is the 22nd lecture, that means we are in the 5th week. You have already taken, all of you have taken 4 assignments, and we will complete in total 12 assignments, after which you will have the final examination. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember, we were discussing the very simple concept of simplex method, that what would be the entering variable, what would be the exiting variable. And before that, on the 20th lecture, which was the last lecture of the last week, 4th week, we were also discussing that concept of primal dual problem, in the sense that they are just intuitive mirror image of each other, in the sense that if when you seeing your picture in the mirror, your left hand becomes the right hand and the right hand becomes the left hand, which means the maximization becomes the minimization and the minimization becomes the maximization. But obviously, I will repeat it, please bear with that the number of constraints becomes the number of variables, the decision variables, and the number of decision variables becomes the number of constraints for the primal and dual. So, whichever is primal, whichever is dual, that is a different question, it can be maximization or minimization. And the greater than sign, less than sign, those conversions have already been discussed. So, we were now based on that, I said that we are going to basically discuss the primal problem, the maximization one, and then basically go and try to solve it in the sense of minimization. One thing you should remember, that we were talking about unboundedness, unique solution, no solution, the constraints do not satisfy, all these things. So, the output which you are getting in the primal problem, you will get the exact same intuitive output in the dual problem also, because that would come out very easily, because if you are trying to maximize in the sense for the primal one, and if it is unbounded, that means it will keep going away from the 0 and more inside the first quadrant. In the same way, when you do the minimization problem, because remember in that case, if x's whatever the x's, s's, w's, depending on how you have been able to formulate the slack and the surplus. So, obviously, slack and surplus would all be denoted by s, but in some cases to make the differentiation we also use the symbol small w, because also remember this nomenclature of trying to basically maximize being z, minimization being w would also be utilized. Now, coming back to this the concept of unboundedness. So, if you have unbounded maximization solution, in the sense when you have the dual problem, it will be just the reverse, where when you are trying to do the minimization, you would not be getting any results, any unique results. Now, when you consider, now coming back to the problem which we left yesterday. So, you are basically trying to discuss that which variable will enter and which variable will go out, and at that stage we discussed that x2 comes into the picture. X2 is one of the actual decision variables. Initially, we started at 0, which is the origin, where x1 and x2 was 0, and the corresponding variables or the values of x3, x4, x5, which was the slack for equation number 1, equation 2 and equation 3, which is basically for plant 1, 2, 3, the corresponding constant 1, 2, 3 were at their maximum value. Now, when we considered, and we also saw that the value of addition for 1 x1 or 1 x2 was basically given by the value of 3 and 5 respectively. So, we considered 5 to be the entering one, for which case x2 came into the picture, and the one which would leave would be that variable for which the decrease in the objective function considering the maximization one would be the least. So, we found out that to be x3. So, x3 is out, x4 is x2 comes in, and the end of the day solution we saw. So, you will basically just concentrate on this identity matrix. So, the identity matrix would be basically one value would be this one value would be this one, and one value would be this one, based on which now you know the objective function value is 30. Why it is 30? Because if you multiply 6, which is the value of x 2 here, this is 6 for x 2, x 1 is not there because the x 1 value is not the basic variable. So, obviously, the x 1 value is 0 here, and the slack of x 3 is 4, x 5 is 6, and x 4 which has left is also not there. So, multiply and also remember the x 2 component adding on to the overall objective function was 5 per unit of x 2. So, 6 into 5 is 30, which you find out as the objective function here. Now, when you consider the next day, so okay, now you will ask a question that whether you should proceed or not proceed. Remember one thing, this point initially was 0 0 and the corresponding values of x 3, x 4, x 5 were there, but now the once you do the iteration, the first move, the values are x 1 is 0, x 2 is 6, x 3 is 4, x 4 is 0, x 5 is 6. So, you have moved from one corner point to other depending on the movement criteria of the algorithm. Now, you will basically again check for the maximization problem. What we checked? We checked that if there is any one the variables which is negative coefficient becomes y, because you have brought it from the right hand side to the left hand side. So, check one, x 1 is minus 3, others are all positive, and positive in the sense that the slacks 5 by 2 is positive, which is doable, and that is a basic one of the feasible solutions. Now, x 1 should enter. So, if x 1 enters, obviously, you will try to find out who would basically be replaced by x 1. So, now when x 1 enters, and as you can see from this graph, as x 1 enters, obviously x 5 leaves. So, if x 5 leaves, again you will basically consider the division of the right hand value column value for the b vector which is being changed, divided by the corresponding coefficient for the pivot column elements, and based on that you can basically find out the pivot not the element, the pivot column, and the actual value based on which you will do the swapping and try to find out the calculation would be the pivot element, which would be the common cell based on the pivot row and the pivot column. Pivot column means where based on which you are going to swap or change. Now, again you basically follow the same policy. That means, you are now trying to, the policy is that don't be too much bothered about what is the equation. Main thing is that the one which comes inside, which is now x 2 x 1, technically that particular overall row corresponding to the basic solutions, which is now basically you have x 3, x 2 and x 1 here. These values in the corresponding cells would be 1. What do I mean by the word corresponding cell? Corresponding cell is that if I am considering x 3 and if I am considering the identity matrix, only for x 3 the identity value would be 1, and for x 2 and x 1 it will be 0. Why? Because once you want to find out x 3, the right hand value which is there in the transformed b vector would give you exact value of x 3 based on which you are trying to proceed. Similarly, when I consider x 2, I consider all the cell value corresponding to the identity value. Identity value means the topmost columns are also corresponding to x 3, x 2 and x 1. So, only the common cell which will be 1 would be for x 2, rest x 3 and x 1 would be 0. Hence, when you find out x 2, it will basically be given by the transformed b cell which is there on the right hand side. Similarly, when I go to x 1, the corresponding values which would be there for x 1 cell, the common cell, if you look from above x 1 and from the right x 1, it should be 1, rest of the value should be 0, because when I want to find out x 1, the corresponding b cell on the right hand side of the transformed b would give me the value of x 1. So, let us check. So, if I consider x3, leave aside z, so these are parameters are 0. So, let us see. So, the basic variables here also x3, x2, x1, x3, x2, x1. So, let us not be bothered about x4, x5. So, x3 cell values for corresponding to x1 is 0, which is fine, x2 is 0, which is fine, x3 is 1, and these values are not there. So, obviously, their effect would not be there. So, when you put the value, actually x3 would be 2, that means the slack value for x3 is 2. When I go into x2, let us check, the x1 cell is 0, which is fine, x2 cell is 1, which is fine, x3 cell values, I am just correspondingly checking, is 0, x4, x5 are not there. So, it is basically half and 0. So, the value which is on the right hand side is 6. Similarly, when I consider x1, again x1 cell values is 1, x2 and x3 cell values, common values are 0. So, the value is 2. Now, as you have transformed it, technically the value has also come down to 36. How we do the transformation is given in the bullet points, which I am just hovering where I am hovering my electronic pen. Now, in the objective function, what it was, I am going slow, but please bear with me. So, what was the objective function? Objective function was basically x1 some factor multiplied by x1, some factor multiplied by x2 plus 0 into x3 plus 0 into x4 plus 0 into x5. So, x3, x4, x5 are ruled out. So, even if x3 is 2, it does not come into the objective function, which is fine. Now, when I go to with the value of x1 and x2, remember the values which I had were basically 3 and 5. That means 1 unit of x1 is going to add up you 3 units profit, 1 unit of x2 would basically add up 5 units of profit. So, let us check 6 units of x2. So, 6 into 5 is 30, 2 units of x1, which is 3 into 2 is 6. So, 30 plus 6 is 36. So, let us check, the objective function is 36, which is right. That means, now we have moved from the second stage, we have moved to the third stage, the corner points, where the corner points now the coordinates is x1 2, x2 6, x3 2, x4 0, x5 is 0, and the corresponding objective function value is 36. So, let us check whatever we did in the row column multiplication. It can be basic, we are doing only the row multiplication in order to basically convert that into the identity matrix, because you remember, I am repeating it, your actual policy was A x is equal to B. So, you are trying to convert A by pre-multiplying or post-multiplying by A inverse, and that becomes I. So, I into x is equal to A inverse B or B A inverse, and that is basically the final result what we are aiming at. So, here the new row would be formed by the concept that the new row is equal to the old row minus the pivot column coefficient. So, obviously, you have pivot column. So, we will take the corresponding element based on which row you are doing, multiplied by new pivot row, and so column wise you will pick up each element which is there in the pivot column, and you will basically multiply the corresponding pivot row which is there, which is basically fixed. And once you do that, very interestingly you will get the values accordingly, which is what I will read out. The values are absolutely given, just pay attention here, you will understand that what you are doing is that converting the rows corresponding to the fact that they slowly get converted into identity matrix. So, in the equation 1, that will change in such a value that the old column was basically minus 3 was basically for x1, 0 0 it was basically for the corresponding basic variables which were there, 5 by 2, 0 and 30 was basically the last value in that 0th row, which was basically the objective function. So, objective function would now be changing from 30 to 36. So, let us check that now minus. So, the pivot column element is minus 3 is basically corresponding to the value of x1, because that was the only contender which is going to enter the system, based on which x1 would come into the system. Minus 3 into the initial new pivot row which you already have is 1 0 0 minus 1/3 into. So, actual value which you get is 0 0 0, which is basically the norm as it should be 0 0 0. 3 by 2 is basically for x4, 1 is for x5, and see interestingly 36 comes out, which is what we have already told about the objective function. When I go to equation 1, which is for plant 1 or constraint 1, that will change according to the concept, where the old column was or row was 101004 minus 1. This minus of 1 is basically the pivot column's corresponding element which is there, which is 1, and obviously the pivot row which is fixed is given as 100 minus 1/3, 1/3 and 2, and the final vector which you get. This is what is interesting, and pay attention to the particular values. Pay attention to 2, because 2 is coming here, which is basically the value of x3 at that stage. So, the corner points where we have reached has a value, whatever the values of x1, x2, x4, x5 is immaterial, we will come to that, but the value of x3 is now 2, as it should be. Now, and these values which are before number 2, I am going to come to that later within 2 minutes. So, when I go into plant 2, which is equation 2, when I do the transformation, the old row minus the pivot column coefficient, which is basically 0. 0 was there already. So, obviously, that overall transformation would not be affecting. Multiply the new pivot row would give us the value of 0, 1, 0, half, 0, 6. So, this 6 is important because 6 gives us the value of x 1. And finally, when we go into the plant 3, which is equation 3, multiplying that, in that case obviously you will be dividing by the corresponding value of the pivot row and the pivot column element. So, when that is done, the value comes out to be, because why we are dividing by 1/3, remember, once we divide by 1/3, this number 3, which is the pivot cell, would basically be converted to 1. That means, we are forcing that to be one of the element in the identity matrix as 1. This is where it becomes. So, it is basically 1/3, and you divide the overall new pivot this whole column, that becomes actually, only pay attention to the last cell, which is 2, which is basically the value of x 1. Now, another very interesting thing is, I am repeating it, please look into it. So, when I mentioned x3, x2, x1 and here x3, x2, x1, so this whole thing is basically looks like an identity matrix. Obviously, it should be the principal diagonal, but do not worry about that. I am just swapping such a way that the B side, right hand side also changes. This has already come out here. So, let us check. I am not interested in equation 1. So, I am only interested in equation 2, 3, 4. So, the values are 0, 0, 1, 0, 1, 0 and 1, 0, 0 is exactly what I get. So, let me use a different color, it will be easy. So, this is 0, 0, 1, which is 0, 0, 1 here. This is 0, 1, 0, this is 0, 1, 0 here. This is 1, 0, 0, this is 1, 0, 0. So, we have basically obtained the actual identity which is marked in color in the row column transformation. Now, we have at that stage, what is the answer? The vector x has basically x 1 as non-zero, which is one of the solutions which we want, x 2 as non-zero, which is the solution as we want, x 3 is a slack which is there, x 4 and x 5 are not there in the solution. So, let us check what are there. X 1 value is 2, x 2 value is 6, x 3 value is 2, x 4 value is 0, x 5 value is 0. Now, we have already double checked, that is 3 into 2 plus 5 into 6 is 36, and that is the objective function. So, our first step is satisfied. So, the vector x, column or row whichever you denote, the maximum value is 36. Now, let us check that what are the constraints at that stage. I should not be doing that, but I will tell you why I am doing that and then I will proceed. Okay, let me first discuss that why I am doing that. The stage when you stop, stage where you have stopped, right. Now, this was an objective function where you are trying to maximize. So, in that rule was basically whatever constraints you brought from the right hand side to the left hand side, if they are negative you will proceed. But let us check, are there any negative values for the constant for the zeroth equation? So, they are not, which means that we have reached the optimum solution, because any one of the containers, if they come into the objective function and replace another, the actual objective function will now decrease from 36 lower. So, obviously, we have reached the peak and we would not proceed. That means, the dy dx is basically on the downward trend now, based on the fact that we have considered the concept using simple differentiation and differentiation concept, which means that we have reached the optimum value. Now, let us go into the constraint. So, there were 3 constraints. The first one was x1 plus x3, x1 was the actual decision variable, x3 was the slack. So, here x1 plus x3, what is x1 is 2, what is the right hand side is 4. So, 4 minus 2, actually x3 is 2. So, is it 2? Yes, it is 2, because you see in the vector which you have just found out, the value of x3 is 2. That means, there is slack, that is unutilized concept of 2 units still left. That means, from plant 1 you have utilized the overall production for product 1, you have produced, say for example, 2 kgs, 2 tons, 2 billion tons, whatever it is, and the overall extra left amount would be 2, which is coming from the slack. So, that means, plant 1 is not operating up to the capacity as it should be, because there are still some material unutilized. Now, let us come into the second constraint. What was the second constraint? Second constraint was 2x2 is less than or equal to 12. So, we have added the slack, which is 2x2 plus x4 is equal to 12. So, let us check what is the value of x2 in the final solution. It is 6. So, 2 into 6 is 12. So, 12 is there on the left hand side, 12 is there on the right hand side. So, the actual value of x4 is 0. So, does it match our answer? Yes. If you go into the vector x, you will see the value of x4 is 0, which is the second last cell is 0. So, that means, overall utilization from plant 2 has been 100%, so that slack for second constraint is 0. So, we have utilized everything. Now, let us come to the third constraint depending on the plant 3. So, what was that constraint? It was 3x1 plus 2x2 is less than or equal to 18. So, we have added the slack, which was 5. So, now let us basically put the values of x1 and x2 in that equation. So, what is it? Is 3 into 2, which is because x1 is 2, 3 into 2 is 6 and x2 is 6. So, 2 into 6 is 12, 12 plus 6 is 18. So, left hand side is 18, right hand side is 18, which means that x5 is 0. That means, the slack corresponding to the third constraint is all 0. So, we have been able to utilize the third constraint corresponding to the plant 3 totally. Now, if we were able to, so this is the situation we have stopped, but are you satisfied? Technically, I am mentally not satisfied, because due to the reason that I would like to utilize that 2 kg or 2 billion tons or 2 tons, whatever is there for slack corresponding to the plant 1 not being utilized is something which is irritating me. But the fact is that if I try to utilize that, I will basically break that, I will basically exceed that constraint, because the only product which I can make in plant 1 is x1. So, if I basically utilize that to make x1, obviously that will violate the constraint. Violating that constraint, obviously it will have have 2 effects, one positive, one negative. Positive in the sense that it will definitely increase the objective function, provided x2 is at the same level. But if you come to the third constraint, you will see that x5 is 0, which means that we have utilized everything. So, increasing x1, it would mean obviously x2 we will have to decrease such that the total amount which will keep produce at plant 3 is kept 18. Now, consider that x5 is still 0. So, if x5 is still 0, x2 has decreased. So, decreasing x2, does it increase our objective function totally from 36 value? If that is true, then I am happy. If that is not true, I am definitely not happy. That is point 1. Point number 2, also remember, it may be possible that if I concentrate on slack number the first one, which is x3, then having an effect would also, increasing it would also mean that there may be some x5 slack which is happening. So, x5 becomes positive. In that case, x2 would decrease. So, if x2 is decreasing, x4 would also come into the picture. So, x4 is also become positive. So, in the sense that increasing x1, and if we have to decrease x2, if we see the objective function is increasing from 36, it makes us happy such that we will be able to go ahead and basically plan it accordingly. But pause here, we know that per unit increase in x1 will give us a profit of 2 units, while per unit increase of x2 will give us a profit of 5 units. So, what is better? Obviously, we will be happy that if x2 increases by 1 unit while x1 increases by 1 unit, the additional profit would be basically 5 minus 2, which is 3. So, considering all these things, you can definitely prove that any further improvement would not be possible. That means, it is possible that at the end of the day some unutilized material is left in any one of the constraints, depending on how you have been able to formulate the problem. Now, let us go into, so I will come to the dual problem of this later on. So, let us consider another problem where you have maximization of 12x1 plus 9x2. I am considering all of them in the 2 dimension one in the very simplistic sense, it can be expanded accordingly. So, there is no issues about that. So, the constraints are x1 is less than equal to 10,000, x2 is less than equal to not 10,000 sorry is 1000, x2 is less than equal to 1500, x1 plus x2 is less than equal to 1750 or 1750, and 4x1 plus 2x2 is less than equal to 4800. Now, if I basically talk on the same parlance as I have been talking for the first problem, it will be, so now I have to basically add the slacks. So, the slack would be, one would be added for the first one would be added for the second one would be added for the third one would be added for the fourth one. So, consider the slacks, I am not mentioning them as x1, let us consider that I basically use the symbol as s1. So, it will be s1 for first, s2 for second, s3 for third, s4 for fourth. So, the equations actually would be x1 plus s1 is equal to 1000, x2 plus s2 is equal to 1500, x1 plus x2 plus s3 is equal to 1750, and the last one will be 4x1 plus 2x2 plus s4 is equal to 4800. So, as I add the slacks in order to bring the equality in all the 4 constraints, the objective function also will change, which will be 12x1 plus 9x2 plus 0 s1 plus 0 s2 plus 0 s3 plus 0 s4 is basically the objective function, and obviously you will have the constraints as x1, x2 and also the slacks s1, s2, s3, s4 as greater than 0. So, you will basically take the simplex direction as constructed by increasing the non-basic solution as I have already discussed, and the entering and the exiting one would basically depend on the maximization on the minimization problem which I have stated, but preserving the fact that your movement would all be along the boundary points corresponding to the basic feasible solution. If no component is negative in order to increase your simplex method considering the maximization problem, you will stop, and obviously it may mean in the unbounded case that the entering variable come again and again such that the feasible solutions would basically keep changing, or they would be basically kept at certain different combinations of all the basic solutions and the slacks or the surpluses, but the objective function will keep increasing if it is on the upward trend. Similarly, in the negative sense, when you are trying to solve the dual problem, it will keep decreasing to negative infinity or in minus infinity depending on the problem how it has been done. So, with this I will close this 22nd lecture, which is the second lecture in the 5th week, and continue to discuss more about the dual primal dual problems accordingly in the next class. Have a nice day and thank you very much.